Okay, guys, you've been working on your math problems, and now comes the point where we explain why we've been working on our math problems, and that's to figure out how much of the drug we're going to give. I've sent you this worksheet. It has different drug problems on it, and you see where it says ordered amount, that's the dose that the doctor wants, and then on hand amount is the concentration of your drug, what you actually have available to you. And we're going to figure out various problems here. Now you notice it also says the patient's weight down here, but if you look at the ordered dose, it says 400 milligrams. It doesn't say 400 milligrams per pound or 400 milligrams per kilogram. So this is not a weight-based calculation, so we can ignore the weight of the patient. Only when it says in the ordered dose 400 milligrams per kilogram or 400 milligrams per pound do we really need to worry about the weight of the patient. Okay, so this one is a straightforward problem. I'm going to show you two ways to do your drug calculations. One is called dimensional analysis, and it's also called scientific notation because it's the one that if you were to take chemistry or physics, it's the one you would use to solve a lot of your problems. It's really hard to make a mistake if you set the problem up right, and you'll know that you set the problem up right because you end up with only the units you want. For example, I can't give a milligram amount of a drug. I need to give a liquid volume of the drug, or I need to give a number of tablets of the drug. So whatever I have in milligrams or grams of a drug, I need to figure out what volume that's going to be to give that drug. And dimensional analysis is really good on that. The other one I'll show you is ratio and proportion. Now, there are plenty of other ways to solve math problems and drug problems, but I find these two to be the simplest. Well, dimensional analysis doesn't necessarily come across as being simple, but you'll know you set it up right anyway. But there's also ratio and proportion, which I'll show you as well. It has some limitations to it. So I'm going to take number 1 on this sheet, and it says the ordered amount. Now, again, I'm doing dimensional analysis here. And the goal is, if we set this up right, then all the units we don't want will cancel out. Okay? So I'm going to do this the long way, just to show you. So this is dose times concentration and if it were a weight-based problem, it would be weight times dose times concentration. Okay? So these are the two formulas you might use, and quite frankly, let's just take this top one off and memorize this one, realizing that some problems don't involve the weight. Okay? So in this particular problem, it says the ordered amount is 400 milligrams. Well, it's 400 milligrams. It doesn't matter what the patient's weight is, so we're not going to even consider that. So the dose is 400 milligrams, and it's very important that you put your units next to each one. Okay? Now, the amount that we have on hand is 2 grams per 6 milliliters. Now, I'm going to flip this dose, I'm going to flip this concentration on nearly every problem. So instead of 2 grams per 6 milliliters, I'm going to write my grams down here, 2 grams per 6 milliliters. Now the problem I have here is that this and that are not the same units. But I do know that there are 1,000 milligrams in a gram. So I can look at this and I can say 2 grams times 1,000 milligrams per gram is going to be equal to 2,000 milligrams. Okay? So I'm going to substitute that 2 grams for 2,000 milligrams. All right? Now, again, this is like a big fraction. This is over 1. So, and let me get rid of some zeros and some units. So the thing about dimensional analysis is that, again, this is a measure of mass. Milligrams and grams are a measure of mass. I can't give a mass of a drug. I have to give a volume of a drug. This is a volume measurement. So I want the only unit left here to be a volume measurement. And since I have a milligram on the bottom and a milligram on the top, that goes away. They cancel each other out. And the same with a couple of zeros here. So what I end up with is 4 times 6 is 24 over 20, and that's milliliters. Now, with the help of our handy little calculator, let me get to that right screen here. So this is 24 divided by 20. That's 1.2 milliliters. So the answer to this one is 1.2 milliliters. All right? So it's weight times dose times concentration, which I'm going to flip upside down. And again, the other thing is I need to make sure all the units measure out. Okay? That's number 1. Let's look at number 2. Number 2 says the ordered amount is 500 micrograms. So it's weight times dose times concentration. Weight doesn't matter because it's not a weight-based dose. It doesn't say per kilogram. It just says 500 micrograms. Times our concentration, which I'm going to flip, which is 4 milligrams and 2 milliliters. Again, we have a problem here. Milligrams and micrograms are not the same thing. There are 1,000 micrograms for every milligram. So if I were to take my 4 milligram, well, first of all, let me reduce that. That's going to be 1 milliliter per 2 milligrams. Because 2 will go into both of those. So I can simplify that a little bit. So I've got 2 milligrams, and I want to figure out how many micrograms that is. So that's 2 milligrams times 1,000 micrograms per milligram. I want to get rid of my milligrams, so that's why I put it on the bottom. So I have 2,000 micrograms per 1 milliliter in this problem. Okay? So I'm going to substitute that milligram with micrograms. So I have 2,000 micrograms. Okay? Now I can do the math, which is 500 divided by 2, which is 250. By the way, micrograms goes away. I don't have any zeros that I can cancel out, but half of 500 is 250. Okay, now obviously this isn't one you could give, you couldn't give this. This would have to be an oral dose of medication. You can't certainly give that in a syringe. That's way too much volume. Okay? All right. Now, let me do one that's a weight-based calculation here. So, number 4 reads 0.5 milligrams per kilogram. So that's the dose. 0.5 milligrams per kilogram. The patient weighs, the patient weighs 165 pounds. Okay, and the dosage is 100 milligrams and 10 mils. Now I'm going to have to do a lot here, so I'm just going to write it as it's written right now. I can get rid of a 0 here and go, there's 10 milligrams per 1 mil. Now, here's the problem that we have. On this one, we need to figure out what the weight is in kilograms, because That's what the dosage is asking for. It's in pounds. We're giving the patient's weight in pounds. We need to convert that to kilograms. So that is probably going to be about 75, 80 pounds. Let's see. It's 165 pounds, and there are 2.2 pounds per kilogram. That's a constant. You need to know that. Pounds goes away. We have 165 divided by 2.2. So let's see what that is. 165 divided by 2.2 equals 75. So our patient weighs 75 kilograms. Okay? So that's what we're going to plug into our equation. Okay? So I have 75 kilograms times 0.5 milligrams per kilogram times our concentration. Again, I need to get, already gotten rid of my kilograms. Now I need to get rid of milligrams. So that's 10 milligrams per 1 milliliter. Okay? Milligrams goes away because I have one on top, one on bottom. The only unit I'm left with is milliliters, which is what I want. So this is going to be 75 times 0.5 times 1 divided by 10. Sounds bad, but it's set up right because my units cancel out. So that's going to be 75 times 0.5 times 1. Didn't need to put that in there. Divided by 10. That's going to be 3.75 milliliters. Okay? So the thing about dimensional analysis is that if you set it up right, you're left with only the unit you want. That's how you kind of check your setup to see if you've done it right. But if you always start out with the weight times dose times concentration, and again, the concentration is the amount on hand or how supplied or any number of ways that they write it. That's the amount you have. Okay? And keep in mind that this could also be a tablet. Take, for example, the doctor wants you to give 10 milligrams. The dose is 10 milligrams. And what you have in the tablets is 20 milligrams per tablet. So this would again be 10 milligrams times, turn this upside down, 20 milligrams per tab, because we're trying to figure out how many tablets we need to give. Milligrams goes away, 0 goes away, which equals 1/2, which equals 0.5 or 1/2 of a tablet. Okay, let me do another one. When I send you the answers to these, I'll try and remember to work them all out for you as well. Let's do, if I can find one that's a real challenge for us here. Well, ooh, that's a bad problem. I was looking at 29. Let's do 29 because I'm not real sure what that turns out to be. Problem number 29. The ordered amount is 500 micrograms per kilogram. This is going to be a crazy dosage, I think. 500 micrograms per kilogram, and we have 1 gram in 500 milliliters. Well, we need to go from micrograms to grams or grams to micrograms. It's going to be not a fun procedure. let's convert this to milligrams and that to milligrams so that our units are in agreement. We'll worry about, let's see, what was a kilogram? 80 kilograms was the weight. All right, so let's convert this to milligrams. So we have 500 micrograms times 1,000 micrograms per 1 milligram. Now again, these are metric conversions that you need to know. I've given you that sheet that has these on there. So these are ones that you just have to kind of commit to memory. So micrograms goes away, leaving me with milligrams. I can get rid of a couple of zeros. So essentially I have 5 divided by 10, which is going to be 1/2. So that's going to be 0.5 milligrams. Okay, because I'll have 5 divided by 10, because 1 doesn't change this any. Okay, so I have 0.5 milligrams instead of my 500 micrograms. So that's going to be 0.5 milligrams. Now, let's change the grams to milligrams. I have 1 gram times 1,000 milligrams per gram. The grams cancel out, and that leaves me with 1,000 milligrams per 500. Okay? So I can do 1,000 milligrams per 500 milliliters. Well, this is interesting because I can, again, I get, whoops, oh, let me erase that first. I'm still trying to get to this part. So I can cancel a couple of zeros here. I've got 10 divided by 5, which again is 0.5. So this is going to be 0.5 milligrams per 500 milliliters. Or pardon me, per milliliter. 0.5 milligrams per milliliter. All right, so let's set this up again. Hopefully you can see it down here. 80 kilograms times 0.5 milligrams per kilogram, that's the dose, times the concentration, which is 0.5 milligrams per milliliter. Well, 0.5 milligrams goes away, kilograms goes away, so I'm left with 80 milliliters. Now, that's a booger. That's a tough problem. Work on the easy ones first. Don't worry about the kilogram weight ones until you got the other ones down. And again, I'll work these out and send them to you. But I want you to work on them too. The other way of doing simpler drug problems is called ratio and proportion. Okay, ratio and proportion. And that's a little bit of algebra, so if you ever wondered what you used algebra for, this is what you'd use it for. Let me find one that would be good for that. We haven't done 3, so let's do number 3, which says the ordered dose is 0.25 milligrams. 0.25 milligrams. And the amount on hand is 1 milligram and 10 milliliters. Per 10 mils. So to set this up, I'm going to write what I'm given first, which is 1 milligram is to 10 milliliters. as X milligrams is, or 20.25 milligrams is to X milliliters. This means as. So this means this is to this is to this as this is to that. So that's how they write it, just with the colon and then the double colon. So this means, so I have the 1 milligram per 10 milliliters is equivalent to 0.25 milligrams per how many milliliters? Okay? So what I'm going to do is I'm going to take the means, or the extremes. These are called the extremes, these two outer numbers. That's EX. I don't know what that is. That's an R. Extremes, and multiply them by the means, which are these two middle numbers. Okay? So let me erase this up here, so I have some room to do that. So what I end up with is I have 10 mils times 25 milligrams is equal to 1 milligram times X mils. That's 0.25, isn't it? 1 milligram times X milliliters. So this is a solve for X kind of a problem here. Wait, let me do that over, because I think I skipped a step that might be important to you. So I have 1 milligram per 10 mils is 25 to X. So now I need to solve for X. So I end up with 10 times 25 is equal to 1 times X. 1 times X. Okay, so that's what we end up with. So this is just X equals 10 times 0.25, which is going to be 2.5. I can work it out on a calculator, but I just know already that that's 2.5 is equal to X. So this is how many milliliters I would end up giving. That's what we're trying to determine here, is how many milliliters. Okay, let's do another. This one's hard to do if you have a weight-based calculation, by the way. Oh, let's do... Let's do 11. Number 11 says that the dose, or the ordered amount, is 1.5 milligrams. And the amount that we have, the concentration, is going to be 3 milligrams and 5 mils per 5 mils. Now I can already tell it's going to be 2.5 milliliters, because it's going to be half of what I've got. But let's work it out. So I'm going to take 3 milligrams is to 5 milliliters as 1.5 milligrams is to X milliliters. Okay, again, multiply these. That's 5 times 1.5 is equal to 3 times X. So 5 times 1.5 is 7.5. So that's 7.5 divided by 3 is equal to X. So let's just see what that turns out to be. 7.5 divided by 3 is 2.5. Okay, so this turns out to be X is going to be equal to 2.5 mLs. So if you ever wondered what algebra was about, that's what algebra is about. If you're in health professions, we use algebra. So that's what ratio and proportion is. It's multiplying the means by the extremes and solving for X. Okay? Now this is just an introduction. I want you to work on these problems. And again, I'll send you how they're worked out so that you're not flying blind on that. Takes a lot of practice. It takes a lot of practice. And even today, I still make some mistakes. That's why it's always good to check your work with somebody else to make sure you've done your math right. Because once you've pushed it into the patient, it's in the patient. And having worked in the hospital environment and having worked in the education department in a hospital, we saw these errors occurring every single day. There were medication errors every single day. And in the next chapter, when we talk about drug administration itself, we'll get into how to avoid some of those. Anyway, so that's it for now. Get to work on these problems, and I will get back with you. So see you later. Bye.